So for this question right here, this is actually a combination of the product rule and the chain rule. And the reason that is because this h of x consists of two functions. The first one we'll call f of x, and that one is, we're going to call that one x squared plus 1 cubed. And the second function, g of x, we're going to call 2 minus 3x to the fourth. So in the product rule, recall that we are going to take this function and multiply it by the derivative of this function, and then add the derivative of this function to multiply by this function. In other words, we're going to say h prime of x equals f of x times g prime of x plus f prime of x times g of x. Just like that. So that means we need to find the derivatives of f of x and g of x. While looking up here, we can use the chain rule because this has an exponent over this internal function right here. And in this case, what we're going to do to find the derivative, well, we take that 3 down just like we would otherwise, and we go 3 times x squared plus 1 squared times the derivative of what's inside, the derivative of x squared plus 1. So that's 2x times the derivative of 1, which is just 0. And putting that all together, we get 6x times x squared plus 1 squared. And we're going to do the same thing with the g of x. So we go g prime of x equals 4 times 2 minus 3x, take away 1 from the exponent, times the derivative of what's inside. This is 0. The derivative of negative 3x is just negative 3. Just like that. So then what we're going to do is simplify to get negative 12 times 2 minus 3x exponent 3. Then we can take our values for f of x, g of x, and their derivative and just plug it into here and simplify. So this gives us x squared plus 1 cubed times g prime of x, which is, let's put that in brackets so we don't mess up our negatives, 2 minus 3x cubed plus our f prime of x, which is 6x times x squared plus 1 squared times our g of x, which is 2 minus 3x to the fourth. Just like that. Now, what we want to do is pull out all the common factors. And we can just look at what we have. If you want, we can rewrite this as negative 12 x squared plus 1 cubed, just to get rid of those brackets, plus the 6x times the x squared plus 1 squared times 2 minus 3x exponent 4. So we're going to look at what is the largest factor I can take out of each term. Well, looking at the constants, I have negative 12 and 6, and I'm going to take out a factor. I would think let's take out a negative 6 because they're going to come out of both quite nicely. So if I take out a negative 6, from here I'm going to be left with a positive 2. So let's do this. I'm just going to do a little bit like this. So I'm going to take out a negative 6, so that leaves me with a positive 2 here. Let's add something in here. And then over here, I have this 6x. Taking out a negative 6, that leaves me with a negative x. Just like that. Actually, I'm going to erase the positive sign. So then I look at the x squared plus 1 cubed. Well, what is the largest one I can take out? Well, this one has a cubed, this one has a squared. So the biggest thing I can take out is x squared plus 1 squared. So I take out x squared plus 1 squared. On this side, that means I have 1 left over, so I have to have x squared plus 1 right here. And over here, I'm taking out the whole thing so I don't have anything left on this side. And now I'm going to do the same with the 2 minus 3x cubed. Well, the largest thing I can take out is the cubed because this one has a 4 over here. So I take out the 2 minus 3x cubed. That means I don't have anything to take out of here and other than 1, so that works there. And then on this side here, I still have 1 left over, so I go 2 minus 3x right here. So writing all that out again, that's a bad 2. That's a terrible 3. Trying to hurry, my tablet's not working for me here. Okay, so let's simplify what's inside here. I have 2x squared plus 2 minus 2x and then plus 3x squared. Negative times negative is a positive, and that leaves me with minus 6 times x squared plus 1 squared times 2 minus 3 x cubed, and simplifying by gathering the like terms, I get 5x squared minus 2x plus 2. That's a terrible bracket, but we get it.